So here's the first concept that we want to look at. Let's graph a function together. Very simple. So something like this.
You said simple.
Simple. Okay, so there is a point here. There is a point here and one here. And I'm going to ask you to follow this graph together with me. Would you agree that this function, first of all, is it a function? I should have asked. Yes, by the vertical line test, this is a function. Perfect. So now, would you agree that between, I'm just going to put some numbers in here. I'm going to say 3. I'm going to say 5. And I'm going to say 8. Would you agree that this function is definitely increasing? The trend shows that it's increasing for any x values from -infinity to 3? I'm not asked, I asked for what value to what value. No. I'm only talking about the trend. For x from -infinity to 3, would you accept that this function appears to be increasing? Good. Between 3 and 5, what does the function appear to do? And what about between 3 and 8? Constant. And what about for x between 8 and infinity? What does the function appear to do? Decreasing. Here's how we write the answer. So what could be the question here? Find increasing / decreasing / constant intervals for f of x. So find increasing, decreasing, or constant intervals for this function. And here's how we present the answer. Not all trends can be in all functions. One function may be increasing all the time. Another one may be constant all the time. It happens. I mean, I wanted to show you all possibilities. So these are all 3. So I will say f is increasing on -infinity to 3. Notice again that we are talking about the x values. So the trend is that this function is increasing for any x value between -infinity and 3. What about f decreasing? On what? Can anyone give us the answer? Is decreasing on? Very good. 3 to 5 union. Very good indeed. A to infinity. Perfect. That's the correct answer. And you will say that f is constant on 5 to 8. Notice that we do not use brackets for these intervals. Okay. So the graph will tell us, from a graph of a function, we will be able to identify whether it's increasing, decreasing, constant. Okay. Here's the next concept. Next concept deals with max-min. There are 2 different types of max-min. One is called relative, also called local. And the other one is absolute or global. Let's use the relative and the absolute. But just remember that you may find them in your book as both relative or local, same thing, and absolute or global. So here's a graph. The graph starts at this point and ends at this point. Obviously, I follow the trend and I see it's increasing till this point. And then I see it's decreasing and decreasing till this point. And then it continues to increase. Agreed? So this must be a very important point. This must be a very important point. Obviously, this one will be important, and also this one will be important. So what is this one? This one is a relative or local, let's say relative max, rel max. Why? Why is it a relative maximum? Because I can show an open interval on both sides of the point where the function values are smaller. That's why this is a relative max. I can show the open interval. Now, is this an absolute max? No, because there are other values higher than it. So this is a relative max, but not a absolute max. What about this point? Can anyone tell us anything about this point? And also discussing in terms of the open interval. So what do you think this point is? First of all, does the function exist on both sides? Can I show the open interval on both sides? Can I show that all function values are bigger than this one? So what do you think that point would be? Indeed, a relative min. Is it an absolute min? No, because there are other values smaller than it. Okay, what about this point? Is this a relative max? No, because I cannot show the open interval on both sides. So the endpoints of the interval will never be relative. They can be absolute or none of the above. So is this an absolute max? Yes, because for this function is the largest possible value, abs max. What about this point? Is it a relative minimum? No, because it's at the endpoint of the interval and I cannot show the open interval. Good, so what is this then? The absolute min. So that's another concept that now we know about a function. Any questions? Any questions? Okay. One more before we choose examples. Okay. Symmetry. So what we learned so far, we learned two topics about functions. One of them was about max min, local max, local min. And the second one was about increasing, decreasing, or constant. This is a third concept that we want to look at, which is symmetry. Let's see if a function is symmetric or not. Do you think functions are symmetric? They could be, but they are not frequently are symmetric. Yeah. Okay. What type of symmetries we know of? You may know these two from previous experience or may not. So one is called odd symmetry, and the other one, of course, is called even. Odd and even does not have anything to do with odd numbers like 1, 3, 5, and even numbers like 2, 6, and 10. Nothing in common. It's just that it's the name that we use for a symmetry of a function. A function can be odd, it can be even, or it may not be symmetric. If a function is odd, can it be even? No, there is only one though. One function, but that function is of no interest to anyone. It's f of x equals 0. No one cares about that function. So no functions, I would say, in general, are odd and even at the same time. Okay, so let's start with an example about odd, and you'll tell me what should the relationship be. So here's a graph of a function. We don't really know this function till chapter 3. Let's graph it. So here's the graph of this function. I keep saying that, but does this graph represent the function? Yes, by the vertical line test, this is a function. Perfect. Here's what I'm going to do next. I'm going to connect 2 points, one from the first quadrant on the function, on the graph, one from the first quadrant and one from the third, with a line segment passing through the origin. So I can do this and connect 2 points, or I can do this and connect other points, or I can do this and connect other points, or I can do this and connect 2 other points. I'm just going to do one. but I can go on forever. Would you agree? Okay. So I'm just going to connect this point with a line segment going through the origin to this point. I'm going to give you the x coordinate for this, and I would like you to give me the y coordinate. And this is a function f of x. So if I know that this point has x as the x coordinate, what will this be? Good, which is exactly, or say it again, say it louder. Of course, thank you. So this point must have coordinates x comma f of x. We just wrote it a minute ago. Very good. Where did I write it? Here it is. Good. Okay. So now, without looking on this side, I'm going to say that, what do you think this is? Say it again. Awesome. And now I would like you to give me this. Don't look at the other side. Do not even consider that. I just want you to say this is negative x. So this would be? Thank you. That's what I said. Do not look and don't think. Just give me that. Perfect. So now I would like you to tell me what is the relationship between this piece from the origin to this point and this piece from the origin to this point. And that is the relationship that any odd function has to fulfill. So if this is 10, what should this one be for sure? Good. If this is 5, this should be? Good. So what is the relationship between f of negative x and f of x?
Distance has to be the symbol in opposite sides.
Perfect. In other words, is this. F of negative x must be the opposite of f of x. So this number must be the opposite of this number. Good. So this is always the case for an odd function. Now I would like you to tell me, look at the graph and say f of x is symmetric WRT with respect to the what do you think? So this is the graph, right? So this is in the first quadrant and this is in the third quadrant.
What does that say?
WRT with respect to. So this piece is symmetric of this graph with respect to what? The origin. With respect to the origin. That's why I drew that segment, light segment, through the origin. Perfect. Let's look at the other situation and then look at problems. Examples. Here's another situation. Here's the graph of another function. This is f of x. I'm going to draw a horizontal line this time. I'm going to use this point, of course, and this point, and please give me the coordinate of this point here, the x coordinate. Very good. And can anyone give us the coordinate here? Very good, awesome. Please do not look at this side and tell me what this is. Perfect. And please tell me what this equals to.
F of negative x.
Very good. F of negative x. Perfect. Now I would like you to tell me what is the relationship for an even function between f of negative x and f of x. Look at the graph and draw a conclusion. Are they opposites? No.
They're symmetrical.
They are,
Equal to.
say it again,
Equal to.
of course. They are the same value. So if a function is odd, it will be symmetric with respect to what? Not the origin. The origin means over. Origin over. So if it's symmetric, if it's even, the function is symmetric with respect to,
Y-axis.
thank you, f of x is symmetric with respect to the y-axis. Indeed. And if you're asking why is this important, you will see in chapter 3 more examples, and you'll understand in chapter 3 that this is important. Here's an example. Here's an example. If I have a graph of a function, I'm asked to graph it, and I know that this is symmetric with respect to the origin, I graph whatever is presented in the first quadrant, and I just copy in the second quadrant, and I'm done. If I know that the function is symmetric with respect to the origin, what I have in the second quadrant, I will copy in the fourth quadrant, and I'm done. I don't have to find more points in there and connect, and no, I just copy. Because I know it's symmetric with respect to the origin. Okay, so here's a function for us. Let's say a 41 on page 250. So this is f of x equals x squared minus x to the fourth. We're asked to show algebraically. We're not asked to graph the function. We are told show algebraically, meaning use this relationship and use this relationship. That's what algebraically means. Don't graph. Show algebraically whether f of x is symmetric. Okay? So, what do I have to determine? Look at these two relationships and you should say, I know, you have to determine. What do you think? What do I have to find? What do I have to calculate? What do I have to determine? Look at these two relationships and say, yes, you have to determine because you don't have it yet. Say it again. I do have f of x. What I don't have is something that appears in both, which is f of negative x. Good. So let's find f of negative x. And this is what we just discussed. What does this function tell me? It says blah squared minus blah to the fourth. So please tell me what to write.
Is it negative x squared
Very good. Awesome.
minus negative x
To the
fourth?
awesome. That's all I want you to say. Because this is how I evaluate the function when x is negative x. Right? I plug it in everywhere. Good. Now I know that negative x squared is perfect. I know that negative x to the fourth is good. So now I have 3 questions to answer. And only one has the answer yes.
Is that sign correct?
Yes, negative x to the fourth will be x to the fourth with minus in front has to be negative, yes. Negative x times negative x times negative x times negative x is x to the fourth power. I cannot distribute before I raise to a power. By the order of operations, I have to raise first to a power and then multiply. So negative x to the fourth is x to the fourth. With minus in front is negative x to the fourth. Is that okay? Perfect. So now I have to answer 3 questions. And there is only 1 yes answer and 2 no answers. Does this equal the original function? If you say yes, then it's even. Does this equal the opposite of the original function? If you say yes, then it's odd. Or none of the above.
So those are 3 questions we have to ask ourselves.
Yes, because it means, is it odd, is it even, or none of the above, or not symmetric. There are no other options. So if you say that f of negative x is identical with a function, then the other 2 disappear, and the answer is yes, it's even. if you say this is basically negative x squared plus x to the fourth, then it's odd. If none of the above, then the function is not symmetric and we have more work to do when we graph it. So which one is yes? Yes, this is the correct one. They are the same. The rest will go away. So this function is even. So if we were to graph this function, we would have graphed it how? Symmetric with respect to the y-axis. Very good. Should we look at another example, or should I look at one more item for today? Yes, of course. So let's take a look at 40. On page 250, we are given f of x equals x squared minus x. Good. The same question here. Just see whether, or determine algebraically whether the function is symmetric with respect to the origin, which means odd, with respect to the y-axis, which means even, or not symmetric at all. What do I have to calculate? Awesome. Good. So?
Negative x squared
Yes?
minus x. Negative x, sorry.
Perfect. Good. How much is negative x squared? Very good. How much is negative, or the opposite of negative x? Good. So now I have three questions. What is the first question? Yes, x squared minus x. What is the second question?
Negative x squared minus x.
Very good. Or none of the above. So there must be two no answers and only one yes. Are these two the same? No. So this goes away. Are these two the same? Negative x squared plus x? No. So what do we conclude about this function? Not symmetric. This function is not symmetric. Its graph will not be symmetric with respect to the y-axis, and it will not be symmetric with respect to the origin. Questions? Okay, one more item for today. It's called the difference quotient. The difference quotient. Okay, so let's start slowly, and then I'll step by step I will explain what it means. Let's look at a function. So here's a function f of x, and I am going to use 2 points on this function. Here's point P, and here's point Q. I will give you the x coordinate for P, and you will give me the y coordinate for P. Thank you very much. So now I am going to give you x plus h. This is a tiny number, h, but you can say it's huge. Right. I have to zoom in so we can see. Right. But this little h is just tiny. So if this is, let's just give us some, let me give you some examples. If this is 2, this is 2.1. If this is 10, this is 10.2. So h is tiny. But I have to zoom in so we can talk about it. Now, can anyone give us the y coordinate of Q? Thank you very much. Awesome. The next step I will draw a line segment passing through these 2 points. And now yes, very good. Now I would like you to determine the slope for me. The slope of this line.
Wait, what just happened?
I drew a line through P and Q.
Oh.
And then I said from here I would like to determine the slope of that line. Can anyone refresh our memory on how to determine the slope? Very good. Awesome. Over. Thank you very much. Perfect. So now can anyone dictate the slope of this line?
f of x plus h.
Very good. That's y2. Awesome. Minus f of x plus 8 minus f of x. Very good. Over.
F of h plus x.
Not f. F. We're doing x now.
Oh, sorry.
Very
X
good.
plus h, minus x.
Awesome. Very good. This is what we call the difference quotient, but I want to simplify it. What is the only thing you can do here to simplify it a little bit? The only thing. I can never get rid of f. F is a function. I don't even have it. Yes? You look at this expression and say, yes, I can.
Combine the denominator.
Very good. Awesome. Awesome. So the simplified form is f of x plus h minus f of x divided by, yes. This is the DQ, difference quotient. Okay, what does it mean? It gives, and I'm going to write this down for you. This gives the rate of change of function f of x between the points P and Q. So it gives the rate of change of f of x. It gives the rate of change of f of x between what? Between P and Q. Okay, we have time to look at one example with the difference quotient. An apple minus an apple, you no longer have apples. That's okay. You have an apple, you give it to me. Well, unbelievably, I can't eat apples though. I'm allergic to apples. Yeah. Yes. Yeah. Good. Very good. So please give me a quadratic function. Any quadratic function you can think of. So we can determine the difference quotient and determine and simplify the difference quotient for that function. So this is what we're doing now. Determine and simplify the difference quotient for the function you create. Please create a quadratic function for us. Anyone? If you can come up with one, I will.
X squared
Very good. Let's say negative 3x squared
minus 4x.
minus 4x. Awesome. Then let's say plus. Awesome. Thank you. This is a quadratic function. We're asked to find the difference quotient. Can anyone dictate? I'm not going to require you to remember the difference quotient, but we already have it right there in front of us. So can anyone dictate it?
Oh, yeah. Negative. Oh, it's.
Well, I'm only talking about the difference quotient. I'm not talking about the function. I'm not talking about anything else. I just need to copy the formula. F of x plus h minus, very good, divided by, good. So now this is the function. This is our f. This is our f of x. I have a couple of questions for you. Do I have this? We just created it. You gave it to me. Do I have this? Now you can say, what is it? But there is nothing I can do to it. Just plain tiny number denoted by h. Done. Question now, do I have this? No, I have to determine it. So please dictate, how will you determine f of x plus h for the given function that you created for us? Please dictate carefully.
Minus
h minus f of x.
minus
Is you multiply the
3x squared.
You have to look at the function, understand the pattern. Once we understand the pattern, you will tell me the correct steps. Negative 3. We just did this with two other functions a minute ago.
F of x is 3x minus 4 plus 2.
We just did this with two other functions a few minutes ago.
Where?
Okay, very good point, very good point. Very good point.
Like, I have
We
nothing.
just did this a minute ago. We discussed the function, we discussed how to evaluate the function. We just did this a minute ago. Here it is. It's in your notes, right? We just did it with a plus h. Now we should be able to do it with x plus h, right? We just did this on page 4. Good, I'm ready. See, I could have not done this with if I were writing on the board. How would I have gone back to pages? Good, gotcha. I'm ready.
So, yeah, -3 squared plus
X plus A.
So what do I have to write? If you don't say parentheses, I can't continue. I have to stop.
Oh, negative.
Yes,
Parentheses,
yes,
X plus A.
good. Then, right, then,
Minus 4
yes,
into
you have to say yes, yes, good. So always remember, I always build on what we covered. So I'm not just going to just throw stuff at you, back at you. Good. Now please tell me carefully how I simplify this.
minus 3
Yes, be careful now.
into X squared
Very good.
plus
Yes,
XH
I refuse to. Okay, yes, I agree with that.
2XH
Very good.
plus A squared
Yes,
minus
yes,
4 into 8x.
very good. I agree with that. Remember, this is what we did on the first day of classes. That's why we did it. So we don't have to review it again and again. If you haven't accomplished that, then you have to go back to the first day of classes. So this is -3x squared minus 6xh, please. Otherwise, we will never achieve what we want to achieve in this class. So now I can say I do have all three pieces. It's 6:15. I don't want to hold you over. You may have